Hey, this is Mrs. Harris, and today we're going to be solving quadratic equations using the quadratic formula. We've seen this before in section 5.2 when we were finding the roots or the x values for parabolas. So now in section 5.6 we're going to revisit it again. So the quadratic formula says x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So let's go ahead and look at our first example. This example says x squared plus 14 is equal to 10x. The first step in solving these quadratic equations using the quadratic formula will be to make sure the equation is in standard form. So we could take a look at this equation. Is this in standard form? Well, to recall, standard form looks like this. It will say ax squared plus bx plus c equals 0. So does this look like this? That's what you have to ask yourself. And you would say, no, it doesn't, because this 10x needs to belong on the other side. So to do that, we simply subtract 10x from each side, and then we get x squared minus 10x plus 14 is equal to 0. So now our equation is in standard form. We just simply subtracted a 10x from each side. That left us with 0 on this right-hand side, and we have a negative 10x here. So this now looks like this. So the next step that we want to do, step 2, is we need to define our a, b, and c values. So a is the coefficient in front of your leading term or the x squared term. When we don't see an actual number here, it's always assumed to be a 1. So a is 1. B is the coefficient of the linear x term. The coefficient of the linear x term is negative 10. C is my constant. It doesn't have a variable associated with it. And c here is 14. So the second step was to define a, b, and c. The third step is to determine the discriminant. The discriminant is b squared minus 4ac. It is what is under the radical sign of the quadratic formula. The reason I want to determine the discriminant is because the discriminant will tell me how many and what type of roots I will be looking at. So let's go ahead and use the formula to find the discriminant. So it's negative 10, I'm getting ahead of myself, squared minus 4 times 1 times 14. Okay? So this becomes a positive 100, and we go ahead and calculate 4 times 14, and that gives me 56. So it is 100 minus 56, and that's going to be 100 minus 56 is a positive 44. And since I have a positive 44, this tells me that I will have 2 real roots. So the discriminant, because the discriminant is because b squared minus 4ac is greater than 0, we'll have 2 real roots. So I should not be looking at anything that has an I in here. Let me just put this here like this. Okay? So we will have 2 real roots from the discriminant. So now we're going to go ahead and step 4 is we use the quadratic formula to find the roots of x. So the roots are x of the quadratic equation x squared minus b plus or minus the square root of b squared minus 4ac over 2a. Well, we know that a is equal to 1, and that b squared minus 4ac we determined was 44. So we've already got a lot of our work done for us. So now we just simply substitute. X is equal to, b was a negative 10, so it's minus a minus 10. Be careful of the sign. Plus or minus the square root of 44 all over 2 times 1. So it makes it a lot easier when you find the discriminant, because not only do you know how many and what type of solutions you're going to get, but you also have it readily available to plug in or substitute into the quadratic formula. So let's go ahead and clean this up a bit. So x is equal to minus a minus 10 gives me a positive 10, and plus or minus. Now, the multiplicative property of roots tells me I can go ahead and break this up. This is 4, the root of 4 times the root of 11, all over 2. Now you know we cannot leave it like this. So we are going to go ahead and say that x is equal to, we have to break it up into our form. Let's see, so we have 10, and it's going to be plus or minus, the square root of 4 is 2, root 11, and all of this is divided by 2. Okay? So now what we're going to do is we're going to split this apart, and we say it's 10 over 2 plus or minus 2 root 11 over 2. Now I can simplify this. This simply becomes 5, and then the 2's were reduced to 1, so it's 5 plus or minus root 11. And that is your final answer. So here we broke it apart. This is equivalent to this statement. So 10 over 2 plus or minus 2 root 11 over 2. This reduces to 5. 2 over 2 reduces to 1. So it is 5 plus or minus 11. All right, so I hope that helps with some of the homework that you guys have.